And it's a continuation. Yesterday we discussed only continuity and differential. It's a vast topic and we could able to cover only that much. And today we will see some of the board related questions. I'm not going deep into the theory part, but I will touch on the first derivative and the second derivative. And let us discuss some problems which generally we will have some doubts while discussion, the questions which students may ask. We will touch on that. And at the end, if you have any queries, you can also ask the specific questions which you would have found out, you can ask me. So we'll try to discuss that also. So with that, keeping in mind, let me share my screen. So I hope you can see my screen here. Okay, so here I have some questions, picked questions from the applications of derivatives. It includes all the types. So this was one of the question which I mentioned yesterday. It came around, I think in 2018 question paper, 18 or 19, the pre-COVID year one batch question it is. But this is actually miscellaneous, our textbook miscellaneous question only. One more added question was there in this one. Find the equation of the normal also. Find the equations of the normal. So that part was the tricky part in this particular question. We had a lot of discussion, isn't it, sir? During our evaluation camp also, we discussed a lot this one. So let us try what kind of difficulties we will face in this question while answering this question. So I hope you understood the question. Find the point on the curve 9y square is equal to x cube, where the normal to the curve makes equal intercepts on the axis. So here one doubt the children may ask us, what is the meaning of the equal intercept, the meaning of that? So the normal is a straight line when we are assuming equal intercepts when they are making this length and this particular length, that is A and B are equal here. A is equal to B. And when while teaching that slope and the straight line itself, we would also touch upon this one. What is the slope and what we will touch upon this one. The line may also be like this. The line may also be like this and this in this part of. So here A and B are A I am giving. Here also the intercept is AA. The length equal, whereas the point will come in negative. Okay, so here the slope of this intercepts will be plus or minus 1. I hope all those idea we have. I don't have to go in deep into that, I think. So here I am assuming the point x1, y1 be the point of contact. Be the point of contact of the normal and the given curve. Point of contact of the point and the given curve. And since it is a point lying on this curve, it will definitely satisfy that equation 9y1 square is equal to x1 cube. We will get an equation like this one. Now, if we differentiate our given curve, 9 into 2 dy by dx is equal to 3x square we get. All these are all everyone will do, all the children will do. So we don't have any issue on this one. So this is 18, sorry, here it is 2y into dy by dx. So that y will come here. And here this is equal to x square divided by 6y we will get. So the slope of the tangent m will be dy by dx. That m is always the slope of the tangent. So a mistake which the children will take is this itself will take as the slope of the normal. So a common mistake here may they will do. So at the point means we will substitute that point here. So we have to insist here, this is slope of the tangent only. Okay, but the question is slope of the normal. So we are just discussing what are all the common errors which the students make. So this is something which I noted, so I'm telling. So slope of the normal here will be minus 1 divided by dy by dx at that point x1, y1. So it will be the reciprocal with the negative sign, minus 6a y1 divided by x1 square we get. And here is the equating to the slope which we already know. It's a previous knowledge. Plus or minus 1 is the slope of the straight lines which they make intercepts, because this will be 135, whereas this line will be 45 in that way. So here plus 1 you will get, whereas obtuse angle will give the minus 1. So tan obtuse will give you the negative value, and the tan 45 will be 1 here. So plus or minus 1. So this value to be equated to plus or minus 1 we will get. So from this we get y1 is equal to plus or minus x1 square divided by 6. One equation, a relation between x1 and y1. And so we can substitute in that equation number 1 here. So the value will be, on squaring, that plus or minus 1 will vanish. So this is x1 cube. Okay, and here, sorry, this will become on square, squaring, sorry, square, and outside we have a square. So here we get 9 into x1 to the power 4 divided by 36 is equal to x1 cube. X1 to the power 4 equal to 4, we will get on cancelling here, 4x1 cube. Another mistake here is they will cancel here the x1 cube on both the sides. That also they should not do. Whenever we are solving for a particular variable, that variable should not be cancelled. That idea we have to insist, keep on insisting them, and they will follow. We have to remind them. So here x1 cube into x1 minus 4 is anyway, that point is not going to give us any extra point in this particular case, but that should be written, and that rejection should be mentioned in the answer. So this part also children may make a mistake. So that also we have to keep on insisting. 1 second. So here after getting these 2 points, we will be getting x1 value as 4 we get. And so y1 value, when you are trying to find out by substituting in this equation, we will be getting 2 values, plus or minus 16 divided by 6, isn't it? So 8 by 3, plus or minus 8 by 3 we will get. So in our textbook, that was the answer, okay, because the question was what is the point of intersection of the normal and the graph. That was the question. Here ends our answer in the textbook. This was given as an objective question in the miscellaneous exercise. But in the board, they asked what is the equation of the normal. There only the confusion is because the slope we have 2 values, plus or minus 1, and the points also we have. So if we do this one with the 4,8 by 3 with the plus 1, 4,8 by 3 with the minus 1, altogether we will get 4 equations in this one, in which only 2 are valid answer. Okay, in order to get that idea, we have seen in our answer papers 4 answers. Some children wrote all the 4 equations. Some children wrongly wrote 2 equations by taking only 1 plus 1 minus, with which point which to be taken. That was a confusion there. Then finally in the board we decided like any 2 is there also, we can give mark like that. We decided, a lot of discussion we had on this question. So here is the point we have to, while teaching itself, we have to insist them to understand the graph of each of this question. Anyway, board will not ask a question which is not in the textbook. That curves, whatever is used in the text only, they will ask. So at least this familiarity of 9y square is equal to x cube, if they had in their mind, probably they will choose the correct combination here. So because one point is 4,8 by 3, it is a point in the first quadrant here. Okay, 4,8 by 3, and another point is here 4, minus 8 by 3 they will get. So the tangent will be passing through like this. This is the tangent, and the normal definitely when you perpendicular line, when you are drawing, it will pass through like this. It will pass through like this. So another normal will be like this. So these are the required normals. So here, the one which gives the 135-degree angle, tan 135, it is minus 1. So they had to actually take a 4,8 by 3 and the slope value minus 1, which will give the correct equation of the normal here. And the second one would be 4, minus 8 by 3. and this portion, this will be an acute angle here. This is an acute angle 45. That is the line which passes through 4 comma minus 8/3 makes acute angle. That will give the positive slope here. Sorry, positive slope m value +1. With this, they had to find out the answer. So I hope we have to discuss this kind of question in the class, which are all to be rejected, which are all to be taken, and what is the reason for these other two we are not considering. All these things we have to insist in the class. So here I think the answer while substitution y minus y1 is equal to minus x minus 4 when they are giving. I think 3y minus 8 is equal to minus 3x plus 12 and 3x plus 3x and 3x plus 3y, is it? 3x plus 3y minus 20 equal to 0 is one of the answer. And the other one with a plus value and the slope is positive, x minus 4. And so 3y plus 8 is equal to 12. I'm sorry, I made some mistake here. 1 second. This is plus here. So this is equal to 3x minus 12. And so bringing to the one side, 3x minus 3y.
Minus 20.
Here somewhere minus 20 equal to 0. In this way, two equations we will get. In case if they had taken wrongly, they will get a two different answer, and that will be a wrong answer to the student for this question. So any other different way of thinking is there for this question? Anybody? Have you noted this one, this question? It asked in the 2018, I believe. Isn't it, sir? Any
yes,
different?
From 18th to 19th batch.
Yes. Yeah. So please insist to think in the diagram. The visualization of the diagram is also, so they will understand the graph is in the first quadrant and in the fourth quadrant it lies. So which are the points to be taken, which normal straight line to be taken, all these ideas they will get automatically. Any discussion on this needed, teachers?
No, ma'am, now clear, ma'am.
Yeah.
Yes, this is the miscellaneous exercise last question.
Last question, yes.
Last one more question.
Yeah, actually it was only the points they asked, but in the examination they asked the normal equation also expanded.
Yes, ma'am.
Yeah. Now another confusing question is this one. Find the equation of the normal to the curve 4y is equal to x square, which passes through the point 1, 2, and also find the equation of the corresponding tangent. Here the misleading fact is that whenever they see the curve and the point, they immediately start using the formula y minus y1 is equal to m into x minus x1. Directly they will not think whether this point lies in this curve or not. So in fact, for this one, this is an open upward parabola. This is an open upward parabola. 1, 2, 3, if it, we are marking, that point will actually come here. This point will come here. It is an outside point, outside the graph. So they are asking the normal which is passing through that point. So they cannot use this formula y minus y1 equal to m into x minus x1. If they directly use that, it will be a wrong answer. So here they have to assume here the point of contact is x1, y1, and they should try to find out that point, and then they have to bring the answer. So I have written here x1, y1 be the point of contact of the normal to the curve. And as previous cases, the same method I have followed, 4y1 equal to x1 square, differentiating the graph. We get dy by dx as x by 2. And the point, if we substitute, we get x1 divided by 2. Equation of the normal at the point x1, y1. That will be in a general form here. In terms of x1, y1, it will be. In terms of x1, y1, y minus y1 equal to minus 2 divided by x1 into x minus x1. Then we have to say it passes through the point 1, 2, and we have to tell them to substitute in the place of x and y, not in the place of x1 and y1. There are also some children make mistake here. So that we have to insist, and y minus y1 equal to minus 2 by x1, 1 minus x1, and simplifying we get the answer as x1 is equal to 2. So when x1 is equal to 2, corresponding y1 value will be 1. So 2 comma 1, the point is 2 comma 1 here. And so they can now use this formula y minus y1 tangent formula and normal formula minus 1 by m into x minus x1. With that point we can find out, and also the slope they need to find out. They can substitute in this one. Otherwise, directly substitute in this expression the value of x1 y1. They will directly able to find out the equation of the normal. So this was another question which is different from other questions. The other questions I felt like it is similar pattern. Any discussion on this one needed? Any point of view, any different point of view?
Ma'am, I won't get it. How the point of contact is 2 comma 1? Yes, they have given 1 comma 2 only.
No, that 1 comma 2, when we substitute that in this one, 4 into 2 is equal to 1 square. So it doesn't satisfy the given equation. But I'm telling that only they should actually substitute in the equation of the curve and see whether the given point is a point on the curve or not. Here, the given point is not a point on the curve. Whatever the formula discussed in our textbook, the curve is given, the point is given, that point is a point of contact it is. Then only they can use these formula to find the equation of the tangent and the normal. Whereas here, 1 comma 2 is not a point on the given curve.
Yeah,
So,
it's not the point of contact. It is the normal
outside,
passes through the point.
Normal passes
The
through that
normal
point.
line passes through the point. That's all. That is not the point of contact.
So we have to
So
insist
point
to
of
the
contact we have to
children.
assume. Yeah.
We have to insist the while finding the tangent and normal, whether the given point is a point of contact or not. They have to really check that. This was also asked in the board paper. This is there in our example, I think. One such question is there in the example.
Yeah.
Whether this is there exactly, I don't know.
No, that is given which passes through the point. Otherwise, a normal to the curve at the point, if they given like that, means it is correct.
Yeah,
we
correct.
Can take
At the point. At the point. The wording will be different.
Yeah, wording is different. That we should be very careful. Which is
we have to be very careful.
Passes through the point. The normal line passes through the point 1 comma 2.
So they just told that it is passing. That point is there on the curve or not. They didn't insist here, no. So we don't know. Maybe sometimes when you try to find out, we don't know. Maybe it may that we are checking here. It may not happen. If it is there directly, we can go for it. The formula application directly we can substitute and find out. So this is a tricky question.
Yeah. No, I can understand, sir, what is your explanation. My doubt is how do you know that it is 2 comma 1? Because you are saying where x is equal to
that
2.
Is what we assumed. No, the point of contact is x1 by 1. I assume, and by here solving, I got the point x1 is equal to 2.
Yes.
Okay, then I am substituting in this equation number 1. Here 1 I am substituting 4y1 equal to x1 square. I have the equation with me. So y1 is x1 square divided by 4. So 2 square divided by 4, we are getting the y1 value as 1. So the point of contact is 2 comma 1.
Okay, now I got it. I thought that you are coming in first, then second column is there. That's what I got confused. Okay, now I understood.
Yes, sir. Any other discussions needed? So this kind of question, please be every time when they get a question and the point, let them check whether it is a point on the curve or not. So with that, I think any other question in tangent and normal exist or not, I don't know. Any other tricky question is there? Sir, have you noted any other tricky questions?
Yeah.
I think these are two which came in my mind.
Yeah.
Okay. So with that, I think we can move on to the very important concept of maxima minima under this chapter. So that explanation using the GeoGebra curve and all we discussed yesterday, when the point is a maximum point, minimum, the slope, what is the change in the slope, when it is a point of inflection, all these things we have seen. It's just a diagram drawing and I'm explaining here. So by observing itself, they can understand, the children will understand A is a point, a minimum happening at this point, B is a maximum point, C is a minimum point, D is a maximum point, like that. So before we give the direct definition here like this, it is better to communicate to them why this, what is the meaning of this f of c greater than f of x for all x belongs to I and all. We needed to convey that meaning. So here, all these vertical lines to the neighborhood of x1, when we are taking the vertical line which is passing at the x1 to A, that point, that line is actually shorter than the other ones. Whereas x2 neighborhood, when we are taking the vertical line at x2 is greater than the other vertical lines in the neighborhood. So that is the meaning which is conveyed here. F of c is greater than f of x for all x belongs to I if it is a maximum point in this case. So B is a maximum point, okay, in that particular interval. So f of c is greater than f of x for all x belongs to I. And so the f of c will be one of the maximum point. Similarly, this one, second case, f of c is lesser than f of c. F of c means all the other vertical lines to the left side and to the right side. And that will be lesser than the particular number. So in that way, that explanation.
Local maximum or local minimum? Like
Local maximum,
yeah,
minimum.
local
Yes,
maximum.
local maximum. Absolute means in all this interval, what are all the maximums we are getting? What are all the minimums? Least, that will be the absolute minimum. Out of all the maximum, the highest, the greatest one will be the absolute maximum. Only one thing that we have to point out here is absolute maxima minima closed interval point will be considered. Whereas local maxima minima, always it's an open interval only. So even if in the question that closed interval is given, local maxima minima will be checked only in the open interval. That we have to insist, keep on saying. So here we have two tests to determine the maximum point and the minimum. We have, it's a familiar for all of us, first derivative test. Just a quick reference to this one. So when it is a maximum point here, let me assume this point is the C here, x is equal to C. So at that point, to the left and right, what is the nature of the first derivative? How the derivative can be useful here? That is what we are discussing. So first derivative will be positive here, and through it is passing over this particular height, and it crosses the other side, it will become negative. And we saw that in a certain graphs yesterday. So that we can diagrammatically we can show, or the true graphical method we can show them and understand how the slope is changing here. And at this particular point, it will be 0. So that is the first derivative test. F dash x changes its sign from positive to negative around the value C. Then C will be a local maxima. Okay, and f dash of c, if it is changes its a sign from negative to positive, because if you draw a tangent here at this point, it will be an obtuse angle here, it will be negative. Whereas if you draw the tangent at this side, it gives you an acute angle, it will be positive only. So in that way, we can expand our definitions. And when we are getting maxima minima, so here it is positive to negative, it has to change it, negative to positive, it has to change. That idea we can convey. So children may ask, what if the first derivative doesn't change its sign? So they themselves will ask that question. So if it is not changing that, this is a one best example. The y is equal to x cube diagram is one of the best example for that. Here to the left side and right side of 0, okay, the 0, how we are getting first derivative, we will find out, and we have to equate the 3x square to 0, x equal to 0, the turning point we will get. But the turning point, whether it is a maximum point or a minimum point, we have to check. For that, they have to substitute values from the left side and from the right side. So if they take a value from 0 to infinity, they can see it is positive. Left side also, it is positive. See, if the first derivative doesn't change its sign, then it will be a point of inflection. So they will ask you why then there is a zero, first derivative zero getting, the slope is zero there. Yes, of course, there is a horizontal line passing through that curve y equal to x cube, but it is not a tangent. Even if it is touching only at one point, it is crossing the curve. So any line crossing the curve, we don't call it as tangent, isn't it? So in that way, you can give that explanation here, I think. Any different way of saying, anybody on this idea? Any discussions? So that point of inflection also we can mention. And then there may be maximum minimum may occur at the point where the first derivative doesn't exist. So these are all the points where a unique tangent doesn't exist. Slope may vary, but that case also we have to consider for the maximum and the minimum. So while discussing the working rule itself, we have to say first derivative equal to 0 case as well as does not exist case also we have to consider. Does not exist case also we have to consider. Those points are all we needed to consider. These are all the critical numbers we have to consider to check the possible points of maxima and minima. In that way, we can give the idea about the first derivative test. Is this clear, teachers, or any other discussions needed on this? Shall I proceed?
Yes, ma'am.
And so here, one question I have given, which is using this maxima first derivative test and finding the maximum and the minimum value. This is our textbook question only. F of x is equal to 2x minus 1 the whole square plus 3. In order to check the maximum minimum, to find the possible points of maximum minimum, we always have to first derivative find out, equate that to 0 to get that turning point. So here turning point is at x is equal to 1/2. And they have to check the sign to the left side and to the right side. So here 1/2 f dash. Okay. We will be taking 1 point. So lesser than 1/2. Here I have taken a point 0. So f dash of 0 is lesser than 0 getting. Here it is negative getting, and here it is positive. So negative to positive, it changes, it's a sign. So we get to the conclusion that x equal to 1/2 is a minimum point. What is the minimum value of the function? It is always f of 1/2. There also sometimes children will stop the answer there. Once they find out x equal to 1/2 is the point, they will stop. What is the maximum value? What is the minimum value? They will not find out. So that also we need to insist. Maximum value means it's at vertical distance they are asking. The first one is just finding where it occurs. So point of occurrence of local maximum minima only we get from this one, x equal to 1/2. And what is the maximum value? You have to substitute in the function. That we have to keep on insisting. So here they get the answer as 3. So this question, but we can do in a different way also. That is why I picked this one. It's not compulsory that the children have to follow this method itself. We can tell them to explore with the different ideas also. So another method also we can apply here, f of x 2x minus 1 the whole square plus 3. So the finding domain and range, that concept in class 11 when we are teaching, or even in calculus here, that perfect square, completing perfect square idea, they would have already known. So using that idea, they will understand here if it's a perfect square is there. If this value is 0, then 3 will be the answer for the function. So at the minimum, the value is 3. So any other value to x, if they are substituting, value will be increasing. More than 3 only they are getting. So in that way also, we can bring the point, minimum point is getting by equating this term to 0. And so x equal to 1/2. And the maximum doesn't exist. That also we can insist here. So what is the max point? We have to say that here no need to substitute. Here itself, if this is 0, 3 is the least that they will identify easily. So this is another method to approach that question. Any different approach have you noticed for this question? Any different thought process, teachers? Shall I proceed?
Yes, ma'am, you can proceed.
Yeah, thank you. So here, in order to check the same idea, finding maximum minima, local maximum minima, we have the second derivative test also. Computing, the working rule is like this: compute the first derivative f dash x, then compute the second derivative f double dash x. The sign change of the second derivative is noticed to determine the local maximum and the local minimum. So lesser than 0, it is local maximum at x is equal to c. Greater than 0, it will give minimum at x equal to c. The proof for this is not given in the textbook, but I can a small idea we will here we can explain. So here, when we draw the graph here, for example, so this is the maximum value that occurs at this particular point. Maybe at x is equal to c, a maximum is occurring at this particular point. So here we have seen the first derivative is positive, we have learned. So let me find out the tangent at this particular point. So one point here I am taking, this is the point x1 I am taking. Let me take another point here. This is the point x2. This is a point x2. So here also, if I try to draw my tangent, it will look like this one. Look like this one. Okay, so here this angle, if you see, if you look at this angle here, let me mark this as θ1 and this is θ2. Okay, here obvious that x1 is lesser than x2, whereas θ1 is greater than θ2. We understand from the graph. Otherwise, use the graphic tools and you will get a clear slope from that. So here, what we can say is that increasing, strictly increasing, decreasing concept, that formula we can bring here. They have learned x1 lesser than x2 implies f of x1 is lesser than f of x2. Then the derivative of that function f of x will be greater than 0. They have learned. Whereas x1 lesser than x2, whereas f of x1 changes the sign greater than f of x2. But in that case, first derivative will be lesser than 0. So this is actually happening here. X1 lesser than x2, whereas the derivative of f dash x, which is f double dash x. F dash x is here greater than f dash of x2. And so it's a derivative. F double dash x will be lesser than 0. It possesses this property, strictly decreasing property. Hello. Okay, in that way here also, here if you take 2 points at these points and the tangent slope, if you find out, we can see that as and when it goes from left to right, it is increasing. In that way we can understand. And so increasing case you will get, and so first derivative. This is how the case comes here. Local maximum occurs, second derivative will be lesser than 0. Minimum occurs means second derivative will be greater than 0. In that way, if at all needed, we can give an explanation to that formula, that theorem. But not necessary, because we in class 12, we are concentrating more on the problems only. But even then, it's a suggested idea. Okay, and now I have a few questions. Anything else to be discussed, sir, in this topic?
No, I have one doubt.
Yes, sir.
Is it local maxima, local minima, and maxima minimum? Both are same. Yes, the working rule is same.
Yes. Simply maxima minima, when we are telling, we consider it as local maxima minima only. Otherwise, they have to mention it absolute maxima minimum.
No, that's what, ma'am. Based in the question, for example, if what is in the screen, show that all the rectangle inscribed in a given fixed circle of the square has the maximum area. Why they didn't mention local maximum area? That's what I.
If simply mentioned a maximum, we refer that to local maxima minima only. Otherwise, they
Okay.
should give us one interval and they have to point out about the absolute maximum
Absolute
from the.
maximum.
Here, there is no such a situation. So we consider it as a local maximum minimum only.
Okay, ma'am. And one more doubt.
Sir,
For
I
few
will also
questions, they are
add my
using
points.
first order derivative.
Yes, ma'am.
I will also add my points like what Mrs. Lasita told. Yeah, and for a function, if there are say 5 turning points, when you sketch the graph, if there are 5 times, if it is turning, so 5, it could lead to 5 either maximum, maybe 3 maximum and 2 minimum. When it is happening, okay, and each point in that local, I mean, wherever you can either say in that, say from A to B, if point C is lying, C is the, if it is a point of maximum, it's a local maximum, you have to say. It's not that absolute maximum. You have to say whatever turning it takes, when we put all together, we say they're all local maxima points or minima points. That one, that's how we have to say, sir. And if it is specifically interval, then only, even if it is only 1 point for the same function, if you restrict the interval and speak about what is the maximum point in that, then you can use absolute maximum. Even if he does not say also, you can tell, because in that specific interval, only 1 time it touches the maximum. So absolute maximum, maximum, local maximum, anything you can say. Anything you can say in that when it is interval. When it is not interval, when it is continuously a flowing graph, a continuously going graph, then how many ever, whatever now she has drawn, and that may all will be local maximum.
All these are these
maximum,
are all maximums,
yeah,
and all these are all minimums.
Minimum. And when practical application problem comes, and we are viewing that problem through a function, we visualize that function, and that when you get the graph of the function, in case how many ever turns it takes, which turn is going to satisfy your practical problem, we find using our derivative techniques and then do. So there is no, if whenever we apply this to practical problems, we never use the word local maximum. That does not come, sir. That we don't use, and even if somebody uses also, it makes no sense. In the sense, it is not appropriate to use, I feel.
Sure, ma'am. Now I understood.
Yeah.
Thank you.
It's not appropriate. That's all. Nothing wrong or right in that.
Okay, ma'am. I had the doubt for too long. I don't know where to.
Yeah. Yes, sir.
Yes.
Thank you.
Anyone else has any other doubts to clear?
No, madam.
Yeah. So for this question, I chose this question because we can approach this one in 2 different ways. So that is why here one is Cartesian method. Okay, and as we see in the diagram, the length is taken as x and the breadth is taken as y, and the circle radius is taken as r, so that you will be getting this AC as 2r. So equation of the circle when we are writing, or the, here Pythagoras theorem is used, x square plus y square is equal to 2r the whole square. And hence we are, so in after explaining that theory, we have to mention the procedure, working rule for the second derivative test. They have to find out which function to minimize and maximize from the question, and express that in single variable function, express that question in the single variable function. And then we have to proceed for first derivative test, first derivative, second derivative. And then depending upon the need, it is not compulsory they have to use second derivative itself, not compulsory. Any method can be used. Okay, there are situations, some cases where second derivative cannot be applied. That I mentioned, I didn't mention here. Here, in case the second derivative is a 0, then we have to use the first derivative test to determine the local maxima and the minima, because it fails here, because only in case it is less than 0, greater than 0, second derivative test is valid. In case this is 0, we cannot say that it is not a local maxima minima point, but the test fails, so we have to use another technique to find out the maximum and the minimum. That point we have to insist. Even if I think in our class 12, it is not mandatory, isn't it, sir? I think in
Yeah.
our textbook, they are simply stopping there. Second derivative test doesn't give us any idea about that one. So say they stopped the answer there. But in order to find, actually, we have to go back to the first derivative test.
We have to go back to the first derivative test.
Yes.
It's mandatory.
Ma'am, in class 12, one example is there, ma'am. In that they stopped just like that. They didn't use a first derivative to determine that.
What problem?
I think in one example question.
What is the question? Maybe they are asking something else.
So there only I thought maybe here they have in examination point of view, probably. 1 second, ma'am. Sorry, I couldn't locate here now.
Okay.
Okay, so anyway, we will follow that we have to go back to the first derivative test to determine if it's like a polynomial question or any other question given. In this case, it won't be needed. And here why I chose this question is it is not compulsory we have to follow with this capital A itself. You can change your question so that our differentiation is easy. So we can write another function. We can give z is equal to capital A square, and we can say that A square is maximum, then z will be maximum. Z will be maximum or minimum depending upon this value. So in that case, in that way, we can square it, make the question simplified form, and then go for the differentiation. So here we can just simply open the bracket. No need of even the product rule here. Simply open the bracket, and the first derivative we can find out x 8r square x minus 4x cube we will get. Equating to 0, we will get the points where it is maximum or the minimum. And here x equal to 0 is not possible. We have to mention that. And so root 2r is the required critical number. Substitute in the second derivative, and the second derivative will be lesser than 0. Here we are getting this as 16 minus 16r square, less than 0 we will get. And so we can decide that this is a maximum point. At this point, maximum occurs. So A is maximum when x is equal to root 2r, and so corresponding y value we will be getting root 2r. In this way, we can prove also that it is a square. The rectangle inscribed in a circle with the maximum area is a square. We can give the insist that the conclusion to be written. So in this way, the question can be proceeded using the in terms of x and y. This question we can also do in a different way in terms of the theta and r. Okay.
Polar components.
Polar forms, yes. Because we can introduce both. What the children feel easy, let them follow that. So here C is the point x comma y, and they also know that this is r cos theta, r sin theta, because any point on the circle will be written in parametric form like that. And so the length will be, this length will be 2 times r cos theta, and the breadth will be 2r sin theta. And so the area will be, here also we are expressing in single variable, but that variable is theta, that's all. So OC will change its a movement from here to here. So which square it will be, whether the C has to be here or the C has to be here or here, that only we are trying to identify here. So definitely that theta will lie from 0 to pi by 2 only. Okay, in that way we can restrict that interval here. And so the area will be 2r sin 2 theta after writing 2 cos theta sin theta in the form of sin 2 theta, and then go for differentiation. Procedure is the same, only it is in terms of parametric coordinates, that's it. So a dash of theta will be 4r square cos 2 theta, and differentiation will be here. One previous knowledge may be needed in class 11. This is a deleted topic, but cos theta, but we have to insist to learn when will the sin theta be 0, when will the cos theta will be 0. All these are all the children should know, even if we are not, I think that trigonometric equations when deleted, probably we will not tell that. So 2n plus 1 pi by 2 is a general solution for that. These are all very important ideas. So we have to insist. And then since it is 0 to pi by 2 only, so this is the maximum point. In that interval we will get. So in that way we can bring the answer again the same way, length and the breadth we can find out. Since it is same, length and breadth are same, we can say that it is a square. Any discussions needed on this one? This is clear? Any different
ma'am,
way
clear.
of any different way approaches there? So we can actually go for both the methods in we can explain in the class. Let the children decide and do whichever method they find it easy. And so here we have a few questions more I have taken. Okay, I have taken a few more questions, which is generally asked in the board examination. So that is why I picked this one. So show that the right circular cone of least curved surface with a given volume has an altitude equal to √2 times the radius of the base. So general question only, volume formula, they have to remember their previous knowledge. And what is the curved surface area? It's a previous knowledge again. So it's better to insist them to go through all the formula. Slant height, how to find. These are all in class 9 and 10 they would have covered. So we have to keep reminding them all the formula. And then express the function which is to maximize here, minimize here the curved surface area S, we have to express it in single variable. R is the variable here. So derivative differentiating to be done with the R. So squaring on both the sides, we will be getting all these expressions. I don't think we need any explanations to this. So S is minimum when S square is minimum, and so second derivative test also here equating the first derivative to 0, we get a point R to the power 6 is equal to, it's not compulsory I think to write what is R. Even if it's like this, I think some questions they'll be able to solve. And here second derivative, they are proving it is greater than 0 for all the R. Okay, and then the question is to express relationship between H and R, √2 times the base R. So for that reason, usually the question is, how do we know we have to do like this? That is the question the children ask. So maybe I will say it's a by familiarity, H by R, that relationship only they have to find out. That is what the answer I gave. Maybe any other thoughts on this? They immediately ask once they reach this one, how to reach the answer. They will struggle sometimes that H is equal to √2 R. So here I have taken to find the relation, the ratio between H and R. They can proceed it in this way. H is equal to √2 R. Any thoughts on this, teachers? Any other different way you approach in your classes? Is it clear? Okay, shall we go ahead?
Yes, ma'am, you can proceed, ma'am.
Yeah. So this is again a semi-vertical angle type question. Nothing new in this one. It is just important, so I have taken it. Usually we have seen this kind of question in the papers. So again, formula by Harshan. What is semi-vertical angle? That we have to tell them. Okay, and find out a relationship for the volume in terms of theta. Here I have taken in terms of theta. So sine theta is from this right triangle. I have taken sine theta is equal to R by L, cos theta is equal to H by L, and then bringing the formula in terms of theta. So here theta is the differentiating variable. With respect to theta, they have to differentiate. So that also sometimes they will have a confusion. Here L is a constant that we have to insist. By reading the question, they have to understand it is L is a constant here. Given, sometimes it will say given slant height, and all that word given says that it is given already, it's a constant, that is a meaning. And then here again sine theta is equal to 0. will give you this answer, which is not possible. And so the second equation will give you tan theta is equal to plus or minus √2. And so this is the critical number here. And then second derivative, find out at that particular point. And then we can bring that maximum volume is equal to 2√2. I think we have 2√2 it is. No? One 2 is gone down here. I'm sorry. So the answer will, some mistake here, some typing error. Sorry.
No problem, ma'am. No problem, ma'am. We all know the problem.
Yeah.
You can go ahead.
Yeah. So it's tan inverse of √2. In this way, we can bring the answer. So all the questions in this category, general way of approachment is like they have to identify which is the maximum and the minimum, and use the, generally we use the second derivative test. If at all anybody is comfortable with the first derivative test, that is also, but it will be very tedious in these kind of questions to find out a point left and right and all, to determine the sign and all. It will be really difficult. So we can insist on that. So in now I am opening the forum to you all. If any questions specifically we have to discuss, then we can go for that from this chapter in general, applications of derivatives. Any other tricky questions is there, sir, in this chapter?
Yeah.
Or teachers, you also can point out if we have to discuss something here. Radhika ma'am?
Ma'am,
Yes, ma'am.
some concepts like we do not have some functions maximum or minimum value. We
Yeah.
cannot find maximum or minimum. For an example, f of x equal to x, if it is defined x belongs to open interval 0, 1, we cannot find maximum and minimum. The same when it is closed interval, we can find the maximum minimum. Such questions, e power x log.
Yeah. F of x is equal to e to the power x. First f dash x will be e to the power x. Here they should know the domain of e power x is, range of e to the power x is always greater than 0. So this will be always greater than 0 for all the x in its domain. So there is no turning point for this graph. That in that way we can communicate this kind of problem. There is no turning point, so no maxima or the minima. It is throughout. The graph also will be like that. It is the graph of e to the power x will be going till plus infinity here, and it is going till minus infinity here. It simply crosses this point 0, 1 here. So this is the graph. So here, this is a previous knowledge. E to the power x is greater than 0 for all x belongs to R. Similarly, log also it's like that, isn't it, sir? Log x, when discussing f dash x will be 1 by x. F dash x will be 1 by x. This is not equal to 0 for any of the x values. In that way, you can bring. This is not equal to 0 for any x belongs to capital R. So there is no turning point. There is no point of maxima or the minima. The graph also we can immediately explain to them. Always bring the graph in mind. So there is no point of maxima and minima to the log x graph also.
Even sometimes no real
observed
roots, they may be getting the same answer. No real roots also
no
we will not have maximum or minimum.
Yes. Any other question if you give, we can discuss maybe. Then one thing they miss is that does not exist case sometimes while finding the critical number. The does not exist case they will miss. For example, the questions like f of x absolute maximum minima while finding 4 by 3 minus 6 to the power 1 by 3. This kind of question while differentiating, maybe they will get 12 into 4 by 3 x to the power 4 by 3 minus 1 minus 6 into 1 by 3 x to the, sorry, here I mistakes, x to the power 1 by 3 minus 1. If you rearrange this term, definitely we will get a term in the denominator also, isn't it? Here and all, if you simplify this expression, 16 x to the power 4 by 5 divided by x to the power minus 1 minus 2 x to the power, sorry, this is minus 1 by 5. So that it comes below minus 1 by 5. Here also that term x comes to the denominator minus 2 by 3. So when they find the equating to 0, when they try to find x here, does not exist case will come. F dash x does not exist when x is equal to 0. That point to be explained. So they usually miss that point. Only they will take the point where
Excuse me,
x
madam.
is equal to
Madam.
8. Yes, sir.
Madam, first differentiation x to the power 4 by 3 minus 1 is x to the power 1 by 3, madam. Maybe you thought 3 as 5.
Yeah. Sorry. Oh, here it
It's
is.
become minus 1 by 3.
Minus 1 by 3. Yeah. Minus 1 by 3.
Correct. madam.
This is coming down, so it becomes positive here. Isn't it correct? Only this is minus 1 by 3.
No, madam. No, madam. Power
This
is
is
positive,
minus 1 by
denominator
3,
negative.
denominator is negative. Here
Instead of,
power is
3, you wrote
minus
5,
2 by
that's
3,
all.
denominator is positive. Yes, correct.
Yes.
In
Just
this way,
3
we will get-
replaced with 5. That's it.
Yes. So on simplifying, we get this as 2 into 8x minus, I'm just writing it for the time being, 2 by 3. In this way, you will get if you express this one. So when x is equal to 0, this is not existing. F dash x does not exist here. That point to be taken. Sometimes children will miss that one. So here also, I think x is equal to 1 by 8 and 0 are the two critical numbers we will get. So that point we have to mention. And then absolute maximum minima, as sir said, there is no need of this method at all. We can simply, everyone knows that, right? I don't think any specific explanation needed for that. That is why I didn't take it. Actually, today is the calculus topic. Today is the last class. So we didn't get a time to touch on the integration.
Yeah.
Even then, I would like to give 1 or 2 suggestions, which I am following in my class. Probably while handling the integration, definitely whatever method we teach them, they will find it difficult only. Even then, maybe we can introduce the questions at a stretch, the similar type of, for example, 1 minus tan x dx, 1 plus tan x dx, the similar type at a stretch. I do like this one. 1 plus, so all these will have same method. So all these questions they will learn at a stretch. Similarly, that way many questions are there in the textbook, like in that miscellaneous also we have like 1 by x cube into x to the power 4 plus 1, 3 by 4 dx, and similarly another one x cube into x to the power 5 plus 1. These are all kind of question which they can follow the similar methods to this one, right? X power 4 minus x the whole power 1 by 4 divided by x to the power 5. So here and all conversion into sin x and cos x, multiplying, dividing by 2, then bring one sin x, addition of sin x or cos x. Same method only for all these 4 questions. Similarly for this one, taking that x to the power 4 common outside, here also x to the power 5 common outside, x power 4 here common outside. That is the method followed in all these type of questions. So maybe it will be useful when we are introducing that similar questions at the same type of question at the same time. So that I felt. And is there any other questions like this, sir, which you in your note?
X squared question, ma'am. Replace x squared equal to y method only for partial fraction.
Partial fractions method.
X squared by x squared plus 1 into x squared plus 3. Such questions.
And similarly, modulus questions are all important. So where the turning point is, we all know this, we are applying even then. I just mentioned it, that's it.
Yes, ma'am.
So these are all the things which even there are some questions where sin 2x come in the denominator. I'm not getting that here now. Like this one question, no, where a lot of questions are there where sin 2x application is there. Divided by root of 9 plus 16 sin 2x. So sin 2x will be part of the denominator A somewhere. So that sin 2x substitution and replacement, that kind of questions at a stretch you can implement. Like this one, even sin x plus cos x divided by root of 1 plus sin 2x. So there are a lot of questions where sin 2x comes in the denominator.
Yeah.
So these are all in my observations I have seen from the chapter integration. And now I would like to give one trick.
For this kind of questions, cos x minus sin x is equal to t, no, madam? Substitution.
Substitution,
That-
yes, yes, yes. All these are same type only. That
That is
cos
easy
x,
type,
that
yeah.
is easy type. If we know
Yeah.
that one particular idea, then
Yeah.
all this type can be done at a stretch.
Yeah.